A straight line graph can also be called a linear relationship. What is a linear relationship? Well, the definition is there. Two variables have a linear relationship and they can be represented by a straight line. Two variables, well, a variable, again, the definition is there, is an unknown. So if you look at the graph in front of you, you've got distance and time. And you can see there for three linear relationships, A, B, and C, so three straight lines, when the distance travelled is 20 kilometres, you can see it took A 1 hour, B 2 hours, and C 3 hours. So it's really important now that we're able to read information off our graphs. Let's take a look at this basic example here. So the graph shows the journey of a cyclist from one place A to another B. So on the vertical axis is distance and on the horizontal axis is the time. The first question says, how far did the cyclist travel? Well, let's have a look. This is where he finished. All right, so he finished after 2 hours and it took him 20 kilometres. So the next bit says, how long did it take the cyclist to complete the journey? Well, we've just said that after 20 kilometres, it took him 2 hours. So 2 hours is our answer there. So we're reading this information from our graph. Just with a gentle dotted line and a pencil, you can just measure it up and make sure you're reading it off properly. If the cyclist were to ride from A to B, then halfway back to A, how far would the journey be? Well, we know from A to B was 20 kilometres. We found that in part A. And then he's going back again. Okay, so he's going half the distance, which is another 10 kilometres. So all in all, he has travelled 30 kilometres. In example 2, we know that the number of rabbits in a colony has decreased. So you can see our straight line is going the other way. And there's the graph for it. On our vertical axis is the number of rabbits. On our horizontal axis again is time. This time is in months. So let's be very aware of what the information on our graph are. So they are our two variables. Part A says, how many rabbits were there in the colony to begin with? Well, to begin with is when t is equal to 0. So we're looking at this value on our graph. So therefore there were 80 rabbits. All right, part B says, how many rabbits were there after 9 months? After 9 months, you can see the dotted line there and going across to there. And so we read that off and we get 30 rabbits. The last part says, how many rabbits disappeared from the colony during the 9-month period? So if we started with 80 rabbits and we ended up with 30, so therefore we're going to have to take that away, and we therefore find that there were 50 rabbits that disappeared during that 9-month period. Interpolating and extrapolating are two very important things that we do with a graph. So we need to know what the definitions are. Now, if you're talking about a straight line graph and you're reading information from the graph that you've drawn, you are interpolating because you are reading from information or data that you've got. Now, once you start extending your graph outside the data you've got, like this red line here, what that information there is extrapolating, because you are now deciding that the data is going to continue to be in a straight line, and therefore it's almost like a guesstimate. So it makes sense that interpolating would be more accurate than extrapolating. Okay, and the further away you extrapolate, the less accurate your answer will become. So looking at this example here, due to poor performance, the value of a company's share price is falling. So you can see there that on the vertical axis we have share price, that's one variable, and on our horizontal axis we have the time again in months. Now the part of the graph that we've got is this dark bit here. Okay, it's the dark bit from there to there. The rest of it, the red bit, is extrapolated. So it's just something that has been continued on. So the only bit of information is that dark bit. So by the end of August, how much has the share price fallen? Okay, August is within that line. And you can see there that by the end of August, we are at $1. So fallen or dropped by $1. All right. At the end of November, what should you estimate the price to be? Notice how they say estimate, because now you're not reading off the graph. So by the end of November, this is this bit here. That's not part of the graph. Our graph finished there. So we estimate, if the graph was to continue on in a straight line, that the price would be $0. So it's an educated guess, and it is extrapolating. It wasn't on the original graph. The last bit there, near the end of which month would you estimate the share price to be? 70 cents. So where is 70 cents? Well, it's this line here. Okay, so they've already drawn it in for us, and we drop that down. And again, it's in the red zone, which is the extrapolating part. But again, it's a guess, it's a guesstimate, and we would guess that it would be around about September that the share price would be 70 cents. So let's be very clear. Interpolating is when you are predicting from information that you have. It is the line, it is inside the data. When you start extrapolating, you extrapolate information, it is a guess. The closer it is to the original information, the more accurate it might be, but the further away you go, the less accurate your data becomes.